In this video, we're going to look at how we can use the repository design pattern that we discussed in the previous video in Spring Boot, specifically with the CRUD repository interface. The CRUD repository interface is in the package you can see on screen. And for us to be able to use this interface, we need to use a slightly different dependency. Until now, when we've been using JDBC, we've used this dependency. But to make use of the CRUD repository interface, we need this dependency instead. This interface provides methods for generic CRUD operations for a repository. And if you haven't heard the term CRUD before, it means create, read, update, and delete. And the Spring documentation has many more details about this interface. When we want to use the interface, the first thing we need to do is to create a class that represents an entity that is in the repository, in this case a database. I'm going to have a repository for a book. In my database, I've got a book table with 4 columns, ID, title, author, and ISBN. So in my class that is representing that entity, I've got the same 4 columns as fields, and this is quite important. I'm annotating the ID field as an ID. With this class written, I can then write an interface that extends the CRUD repository interface. Now, CRUD repository is a generic interface, so when I extend it, I have to provide class names for the type of entity that the repository works with and the type of the primary key. Now, the primary key is ID of type int, so we use the class, the wrapper class, integer. Whenever I want to make use of the book repository, I just put it in here, and because of dependency injection, the inversion of control container will generate the required instance and insert a reference to it in here. And this means that our service class can then make use of that repository. Here we are, there's an example, book repository.findAll. In this example, what I'm doing is getting all the entity objects and converting them to data transfer objects, the reason for which will become more apparent in a later video, but for now, just accept we're doing that. Naming convention becomes quite important when we're using CRUD repository. We know in Java that method names and variable names are written using camel case. That is, the first letter is lowercase and any subsequent words will begin with an uppercase letter. Now, the CRUD repository interface assumes that there are corresponding table and column names in the database that must be written in snake case. So if I have a variable called book ID written in camel case, then in the table in the database, there will be a column called book_ID, which is the snake case version of the name. And this will be true of tables as well as columns. The CRUD repository makes available to us quite a few methods, and we'll see examples of that as we look at the example software in a moment. If we want to add our own methods to our specific repository, we can do so by writing into the interface methods, and as long as we follow the naming conventions just discussed, these methods will work without the developer having to write any extra code. And when you're writing these methods into the interface, IntelliJ will provide some context help to make sure that you get the naming right. Sometimes our additional methods will need to use non-standard queries, in which case we can write our own custom queries into the interface. And here's an example. FindAllBooks is going to get from the book table the ID, title, author, ISBN, and a count of how many copies there are for this book. What we're doing in this query is writing all the SQL for it. And then when this method is called, this query will be run, and the entities that are generated by that query will then be returned, in this case as a collection. But we must make sure that we have an entity class that corresponds to the results of this query. And so we've got this book copy view class that will have 5 fields. ID, title, author, ISBN, and an integer for the count of copies. The example that we're about to look at was started using this initializer. Notice that we're using the Spring Data JDBC dependency. And as we look at this example code, look out for the database migration, entity classes, repository classes, how we make use of those repository methods, also what we've done in the application properties file, and the custom query. Let's start off in the application properties file. For this example, I wanted to introduce a migration for a database that already had tables in it. And you'll see that what I'm doing is adding 3 tables to an existing database. Therefore, to ensure that the migration will occur, I add this line into the application properties file. And what this will do is, in the existing database, which must not have a flyway schema history table. So if yours has got it, delete that table and then apply the migration and everything will work quite happily and a new history table will be created. Let's take a look at an entity class. Down here I've got a separate package for the entities. Here's book, which we saw a few minutes ago. Those are the fields into which the column data will be put for each entity. We're identifying with this annotation which of these fields is for the primary key. We're using the Lombok annotations for an all args constructor and getters for each one of these fields, which means that this entity is going to be read-only, and that's why we've used the final keyword here. It also means that instances of book will be what is known as immutable. That means they cannot change because there are no setter methods. In copy, we've done something similar, except we want to be able to change the status ID. And so we've got the getter annotation for all the fields in this class, and we're applying the setter annotation only to status ID. This is the book copy view, which again is an entity, but this time it's for the custom query that we were looking at earlier, and an entity for copy status. Let's take a look at the book repository. You'll see that this is an interface, and it extends the CRUD repository. Let's take a look at that. Control-click will show us that in this repository, we've got a number of methods. Let's not get too tied up at the moment in all the generics. Let's just focus on the methods. We can save an entity. We can save a list of entities. We can find an entity by ID. We can see if an entity with a given ID exists. We can find all entities in the repository, find all entities that have got the same ID. We can delete by ID or delete a given entity, or we can delete all that have got the same ID or delete all in this list, or we can just delete everything. And this will give us a count of how many entities exist in the repository. Now these methods are all available to the book repository because book repository extends CRUD repository. And we're saying that the CRUD repository is to operate for entities of type book, and the primary key of each of those entities is of type integer. And that's all we need to write for the book repository, and we'll be able then to make use of it. Let's look in the book service, and we can see here that we're going to find all books in the book repository. We haven't explicitly written that method, but we've inherited it from the CRUD repository. And so we can just execute this, and through dependency injection, that will all be done for us. And so this will give us a collection of book entities. We can iterate through that collection, and for each book B that's in that collection, we can use it in some way. Now in this example, as I mentioned earlier, we're going to convert the entity into a data transfer object. So the book DTO has got fields that correspond to fields in the entity. And what we're going to do is use a DTO factory. That class implements the factory pattern. You might want to go and do some background reading on the factory design pattern. And we're going to create a DTO from an entity, another create DTO, this time using a different entity. This is an example of overloading methods. They've got the same name, but the parameter type is different. And therefore, when we call create DTO and pass a book as a parameter, this is the code that will execute. When we call DTO and pass book copy view as a parameter, it will be this code that executes. And this is an easy way of factoring out of all the various classes that would want to create a book DTO, factor that creation code out, put it into the factory class, so we've got the creation code in one place only in the entire application. Then every time we want to create a book DTO, we just call that create DTO method, passing in a book entity, and we will get back a book DTO object. Notice how we are grouping the various classes by package that is related to a concept. So here we've got the book concept. We've got a book repository that is used by a book service that is used by a book REST controller. Similarly with copy, a copy repository used by a copy service that is used by a copy REST controller. And the pattern of usage is the same all the way through this. Let's take a look at the copy repository for a moment. As well as extending the CRUD repository, this time for copy entities whose primary key is of type integer, we're adding two methods of our own. Count by book ID, so this will return an integer that is going to count all the copies that have this book ID. And in the second one, we're going to create a stream of copy objects that have this book ID. In the copy service, when we want to stream, we can call from the copy repository the stream all by book ID. That will return a stream that we can then use to map. So we're going to take a copy and convert it to a copy DTO. And so that method will then result in a stream of copy DTO objects. And then we're going to collect that into an array list. If we want to call find number of copies of book, we provide the book ID. And this method will call from the copy repository the count by book ID method, which counts all the copies with this book ID, returns that number as an int, and then this method returns it to whoever has called the method. In the book copy repository, as we saw earlier, there is a method that we've added that has got a custom query. So when find all books is called, this query will execute. And that method is called here in the get alternative summary of books. And we're going to call find all books, which will return, as you can see there, the result from the custom query. With these concepts in mind, you should be able to start writing some of your own applications, making use of the CRUD repository interface. Inevitably, you will have more questions, and so you should do some background reading, specifically about CRUD repository, and also about some custom queries that you might want to make in your repositories. This is a useful resource here, but please, at this stage, only focus on native queries because we're going to look at JPA and JPQL in a later video.